Welcome back to the channel. Today we will be solving Starters 136 Sum of Modes question. Okay, so you are given a binary string and let f of t be the number of modes of string t. You need to compute the sum of this function for all possible substrings of your string. Okay, mode of a string is a character with maximum frequency. If multiple characters have maximum frequency, all of them are said to be modes. Now, in your string, you have only two types of numbers, 0 and 1. So the mode will be either 0 or 1 or both 0 and 1. Now, mode of a string is a character with maximum frequency. So, now, since you have only zeros and ones in your string, the possible answers for f of some substring will be 1 or 2. It will be 1 if the sum of ones and zeros are not equal, because if the sums of ones and zeros are not equal, then any one will be the greater count. So that will become your mode. But if your count of ones and zeros would be equal, so then the function would have two modes because both of them have same frequency. So basically you need to calculate those subarrays which have this function value is equal to 2, because you know कि rest of all of subarrays will have mode is equal to 1. Okay, if we think this question in two pointers approach, what does two pointer approach say? Suppose I have any binary string. At my ith index, I will calculate the answer for all of subarrays ending at ith index. So I will consider all the subarrays in this range and calculate the answer. That would be the answer for the ith element. I will sum up all of the answers for all of the elements, and that would be my final answer. So what the approach says. Now, if I have some string like this and I have to find all of the substrings, means I have to find the sum of all of answers ending at this index. Now, at this index, I have 3 zeros and 4 ones. So, if I want to calculate how many substrings ending at this index will have mode will have number of modes is equal to 2, means at this index I am having one extra one over here. So all of those indexes by which previously there is one extra one, if I remove that part of the array, then the remaining array becomes a substring having mode equal to 2, sum of mode equal to 2, right? So now in this example there were 4 ones and 3 zeros, and if I say कि I want to calculate all subarrays which are ending at this particular index, which means my subarrays will be from here to here. So out of all these subarrays, I have to find the number of subarrays having same count. So I will try to trim elements from the start. Like now example, at my ith index I have one extra one. Okay, let the count be anything and the difference count is 1. So I have one extra one. Okay, let's take some example like this. So I want the number of indexes such that there is one extra one up, up to that point. If I calculate this, then over here there is one extra one. Okay, if I do this, still there is one extra one. Means basically, if in a map I store the number of occurrences, that in that this difference between 1 and 0 is present this number of times, then I know कि those are the number of sub-arrays having mode is equal to 2. Because now let's take this sub-array for example. I have to calculate the answer ending at this index. So I know कि there's one extra 1 over here. So I have to trim one extra 1 from the start. So if I trim this one, then this is my one answer. If I trim this part, this is another answer. So there were two instances from the start where the difference between counts of 1 and 0 was 1. So the number of sub-arrays having function value is equal to 2 will be that count. So it will be 2 over here. And for the remaining all sub-arrays, my function will be 1. Value of function will be 1. Now let's implement that thing. Okay. I have a map which stores the count for every type of difference. Okay. This contains count of numbers having count of ones. This is having count of zeros. Okay. Now I increment my count of 0 and 1 as per it. Now the difference between ones and zeros, I want the count of those many differences occurring previously. So those are my twice elements and the remaining is in left. If I am on index I, then there are I plus 1 total subarrays which are ending at the ith index. So I calculate twice as this, the count, and left as the remaining. And then corner case, if I end at equal number of ones and zeros, then I have to add that complete subarray as well. Okay, and at the end I just added twice into 2 because that answer is 2 plus left into 1, and then I will have to append this value also in the map. So I appended the difference value in the map, and then sum of all of these answers will be my final answer. The link to this code will be placed in the description. Thank you guys for watching. If you want any other uh, exp explanation for any other question, let me know in the comments. Thank you for listening.